Good morning. Welcome to our first webinar of 2022. My name is Turney Foshi, and I'm the Communications Manager for Southern States Energy Board. This webinar is a continuation of the educational series we started last year. So far, we've covered topics such as electric vehicle growth, energy storage, and carbon capture, such as our program CCARB USA. All available now on our website on the webinar archive page. You can view every webinar we've hosted so far. This one will be on there as well. Today, we'll be joined by 4 experts to discuss the growing need for critical minerals and rare earth elements. So what are critical minerals and rare earth elements? Critical minerals, as defined by the U.S. Geological Survey, include well-known elements like aluminum, nickel, magnesium, zinc, and lesser-known commodities like gallium, rhodium, hafnium, and europium. They are considered critical because of their supply chain necessity and lack of viable substitutes. Rare earth elements are critical elements, but they are semantically separated by their being chemically similar to one another, harder to extract compared to base metals like nickel or platinum, and because of their wide use in digital technology. Everything from the phone in your pocket to your vehicle's catalytic converter or its batteries, if you drive an EV, make use of critical minerals. The official list of critical minerals is not without its critics. Some claim that both copper and uranium should be included, and the list has evolved over time, with commodities like helium and strontium no longer being considered critical to matters of economic and national security. Currently, China controls 80 to 85% of the world's supply of rare earth elements due to their heavy investment in mining operations in Africa and Latin America. And environmental considerations can sometimes stymie efforts by American industry to close that supply gap. For example, in Georgia, there are efforts underway to open a titanium mine just a few miles from a national wildlife refuge, but some, including those in the state's legislature and the White House, are reluctant to express enthusiasm for the project. The arguments between balancing environmental concerns with supply needs will continue to intensify in the coming years as innovative technologies and low carbon solutions drive that demand for critical minerals to new levels. Just yesterday, the White House finalized amendments to its Buy American requirements that create a framework for agencies to buy select materials, such as critical minerals, mined in the U.S. at higher prices. It's a move that may bolster domestic production. And our member states are also showing action on the issue as well. We're currently tracking around 10 bills in various legislatures within our membership that seek to study and incentivize critical mineral and rare earth extraction. Should any of those measures pass, you'll find them in our legislative digest, available in preliminary form this July. Make sure that you're signed up for our newsletter to receive notice when the digest is available. We have a packed agenda today. We're going to be covering everything from how industry and government is incentivizing critical mineral production to how these elements can be recovered from byproducts and put to use. Please, just a quick note, please use the Q&A function at the bottom of the screen should any questions arise during the presentations today. And we'll fill any time we have left at the end of the webinar today with a short Q&A. Okay, so first up, we'll be hearing from Dr. Grant Bromhal. Bromhal, sorry, I'm probably butchering that. Grant is the acting director of the U.S. Department of Energy's Mineral Sustainability Division, and he's here to discuss the goals of its carbon ore, rare earth, and critical minerals initiative. Thanks for being here today, Dr. Bromhal, and go ahead and get started with your presentation for us.
Great, thanks so much. Can you see my, I'll make it bigger. Can you see my screen okay and hear me okay?
Yep, that's perfect.
Okay, great. Yeah, so first, thanks for the invitation to speak. Excited to be talking to this group about an area that I think has a lot of promise looking into the future. I I'm going to start. So I will mainly talk about our core CM program, some of the initiatives that we have here in DOE and in our mineral sustainability division. So I'm part of the Office of Fossil Energy and Carbon Management. Many of you, I think know us well. But I wanted to note that just in the last couple of weeks, there's been a release of our what we're calling the one-year supply chain reports for the clean energy transition. So what these are 13 different technology areas, and there are 7 different agencies. These are just the ones that were produced by DOE and summed up in this America's strategy for the clean energy transition. So I encourage you to go ahead and look at that. You can see carbon capture, energy storage, neodymium magnets, fuel cells, platinum group metal, solar, wind, etc. In this. So there's a lot of interesting information there, looking towards the future of what the needs are going to be in the transition. Here are several of the recommendations. I'm not going to read through all these. I'll make sure you get a chance to see these slides so you can have a chance to see them. But increasing raw material availability and expanding domestic manufacturing capabilities to allow for diverse and secure supply chains, foreign and domestic. I just want to augment something that Fashi mentioned at the beginning. There is a rare earth element mine here in the U.S. that's operating, but any materials that get produced from that have to go to China basically now, because we have essentially no manufacturing capabilities in the U.S. And so expanding maybe is generous. We need to create domestic manufacturing capabilities. We had these several decades ago, 40, 50 years ago, and we've kind of lost them. And so now there's investments being made by DOE and others to try and bring those back. So what my division is about is looking at unconventional and secondary sources, in particular, coal-based resources. So here's just an example of the resource potential that comes from coal. 11 to 17 million tons of rare earth elements from known coal reserves. So this gives you a sense in the coal waste so this is in currently produced amounts of coal. This is with current production about 30,000 tons per year of rare earth elements. Recognizing, and just to give you a sense of where that fits, it's only about 10,000. In the last, let's say, 5 or 6 years, the amount of rare earth elements that have been in demand in the U.S. have been between around 10 and around a little less than 10 to a little more than 15. Now that's expected to grow to over 100,000 tons per year within the next couple of decades, but because of the demand growth. But this kind of gives you a sense of what things are what the opportunity space is. And within our program, so I want to point all of you to our there's a whole series of work that has been fostered by DOE and FECM. We have small-scale pilot projects that have demonstrated that we can take coal refuse, coal ash, and acid mine drainage and produce high purity rare earth elements from those at a small scale. And we've had feasibility studies for large scale projects and advanced separation technologies to improve cost and environmental performance. All this information you can find by going to this NETL website if you're looking for more information than what I can share in these brief remarks. I want to talk in detail about our core CM initiative. So this is a regional initiative. We're trying to assess the regional opportunities for critical minerals, rare earth, carbon ore that can be turned into high value carbon products. We have for each of these regional coalitions. We have broad-based teams. We're trying to understand what the resources are in those regions, not just what are the minerals and materials that are available, but also what kinds of facilities are there, what's the infrastructure, what's the workforce needs and availability that might be there, especially as we're looking towards a transition and looking to help catalyze economic growth and job creation in these regions. And so this is just, I'll let you read that in your leisure. It's basically what I just said. So we're in phase 1 of our core CM initiative. These are basically doing assessments across each of these basins. This core CM initiative began back in October of last year. It's a 2-year phase 1 focused on identification and characterization of carbon oil-based resources and other conventional and other unconventional and secondary resources within these regions, helping understand what are the technology needs to enable future deployment, understanding the industrial and energy needs, and beginning the development of a strategy for how the region's resources can be applied. And then additional phases will include the building of regional technology innovation centers and implementation of regional strategies as we move forward. Here are some of the major themes that we're looking at that kind of cross-cut all the different core CM initiatives. Being able to collect and share data so that we can have more work assessed, environmental justice, characterization methodologies, separations and extraction processes, et cetera. And then I thought I would end by just sharing, so you may or may not be aware of some of the work that's going on now because of the bipartisan infrastructure law that was passed last November. But there is a lot of work that's related to critical mineral space. There's some battery specific things, and there's an NOI out there. I put a link down here. And in the critical mineral space, there's an RFI for our RE demonstration facility. In the battery materials, there's $3 billion, that's with a B each, so more than $6 billion there. And for the RE demonstration facility, that's $140 million provision. So that's all I have. Hopefully that's good for beginning the discussion. See if you have any questions.
Awesome. Yeah, thank you so much, Grant. If you just want to go ahead and stop sharing your screen, and we'll go on to our next presenter. It's always great to hear what our friends at DOE are up to. Please remember to use the Q&A function at the bottom of the window should you have any questions for Grant or any of our upcoming presenters. Up next, we have Dr. Michael Karmis. He's the recently retired director of the Virginia Center for Coal and Energy Research, here to discuss the Evolve Central Appalachia project. Please tell us all about it, Dr. Karmis. I think you might still be muted. There you go.
I'm okay. Let me share screen if I can. Can you see the screen here now?
Yep, that's perfect.
Yes, good morning, everyone. And I appreciate following our friend from NETL who provided a very good overall preview. I will talk specifically about one of the partnerships that he mentioned, which is the Evolve Central Appalachian Partnership, which we consider it as a major public-private coalition. I have recently retired from Virginia Tech. I still help on this project. There is a new PI that will appear at some point. Sorry about that. There will be a new PI that has taken over this particular project, and he will follow from there. Let me see if I can somehow operate this. Okay. So I want to provide the acknowledgement and disclaimer that goes with all the DOE projects, and we appreciate their help. And also to say that the folks at the Mineral Sustainability Division have been extremely helpful to work with us on this project. We have a number of people involved as researchers who have contributed to my presentation, also a number of supporting companies. And I put here what is core CM, but Grant has already defined this, so I don't need to go any further on that. What is Central Lab first? We have developed a Central Lab sort of map based on two different classifications. One is the administrative classification that comes out of the Appalachian Regional Commission, and the second is the geologic USGS classification coming on the basis of coal regions and coal fields. And in essence, if we put these together as we did and merge them in a way as geology doesn't consider county borders, but other definitions do, we came up with what is our sort of jurisdiction within this project. And you see it there also in terms of the various counties involved, just for convenience. Now, we have a truly private-public partnership. Virginia Tech is the prime contractor and the PI. We also have involved the other two major Central Appalachian universities, the Mining Engineering Department at West Virginia University, as well as the Mining Engineering Department at the University of Kentucky. Between three of us, we are all the mining-related programs within Central Lab. On the left-hand side, you will see a number of consultants that are part of our research team. I would try to two comments about them. They also have been involved in other projects with SSEB, so they're quite well known individuals, but also the fact that all of them have been involved for many, many years with issues of coal properties, coal geology, coal reserves. And we have an enormous unpublished bank, if you will, of information regarding coal stratigraphy, which will help quite a bit this project to add to the public information. In the middle, you see a number of other entities who are very important to our project. Our next speaker, for example, who knows more about fly ash than anybody, I'm sure he will make some comments in his presentation that follows, which is Danny Gray. The SSEB also has helping us with public engagement. And then on the right-hand side is the government portion of it by having the Oak Ridge National Lab, the U.S. Geological Survey, and the Virginia Department of Energy. I would also like to make some attention or bring some attention to our Community College Coalition, which covers community colleges or the major community colleges in the states that were all engaged, which is Virginia, Tennessee, West Virginia, and Kentucky within these borders. So if I can follow that, I want to show you also this. Our proposal was endorsed by a number of companies that represent the land and mineral owners who are critical to these projects, coal producers, gas producers, power companies, economic development entities, technology companies, associations, and also international connections with people who are doing significant amount of work, particularly Australians, both at a major Australian university and the Australia Government Research Agency. What you see there is 90% of coal produced in Central Lab is represented by the coal producers that you see there. I also mentioned, as I said, the effort that we have developed to try to make this a project that involves a community. This is a community effort towards what we're trying to achieve, not just one university or anything like that. So some of the priorities and principles, I won't go to everyone, but I want again to stress the factor of stakeholder community that we're pursuing. Many of the other points have already mentioned by Grant. I'm not going to go to it, but I will say that our project and our coalition is looking at process and practices that have zero impacts. In other words, we're looking at what we call not just sustainable, but responsible sourcing, both in terms of mining and in terms of processing. We're looking for a social framework that will encompass the kind of work we're doing under this project to provide equity and justice. For example, We don't want to deal with techniques which are dirty. We don't want to deal with techniques that they're using huge amount of waters, and we don't want to develop processes that create an enormous amount of waste. Even if they're cheaper, we don't want them. It's as simple as that. So these are the rules. Not only we, the community doesn't want them either. The investors don't want them either. If you look at the US, something like 33% or 1/3 of all available managed assets goes to projects with high ESG classification. If you look at the global side, again, you will see 1/3 of all the global money, this is according to Bloomberg, goes to projects with high ESG performance. So if you don't achieve this, you are not getting a significant amount of the monies involved. The next thing also to mention is a recent report from McKinsey consultants that very clearly said that 2/3 of the average company ESG comes out of their supply chain. So we expect to see huge restrictions from people who are using the products that we develop. And a good example was the most recent announcement from Tesla that they totally will get away from cobalt, which is considered a conflict metal. And recently, Mercedes-Benz is another one who said we'll only collect raw material from what they call certified mining sites. I'm not sure what is a certified mining site, but I would say a responsibly mining and processing site. So we're very much into this. We have a number of tasks under our projects. I don't want to go to all the details. I will mention just very briefly something about what I highlighted with yellow. I will also mention that SSEB and us working together on stakeholder outreach and education. And we have actually meetings going on this week and next week. We have a very big public opening with an advisory, a stakeholders advisory board who have created our advisory committee, and the public and the elected officials also will attend. Is scheduled in Abington, Virginia. So what we're trying to hit here is we're trying to enhance the database that already exists with also adding data that we have that are not publicly available. We're trying to develop better geostatistical methods and techniques into a geologic model that will give a more accurate representation of what Grant shows in the beginning of potential resource volumes. We want to totally reduce that volume from restrictive aspects, either due to ownership or legal restrictions or depleted mining, lack of access. And I would like to say that only certain individuals who are certified as competent persons can report resources and reserves. And our coalition, our research team includes a number of those companies and individuals, so we have a good understanding of that. To give you an example, what we have done so far is to try to develop a little bit of our qualitative separation between high resource potential, moderate and unknown potential. You can see a number of elements there and how they might be in the various states that we represent. And this is just one qualitative rather than quantitative approach to what we're doing by the number of samples we have or we plan to collect. We have certain SIMs within these areas that we feel have been well sampled already, although we have certain, let's say, questions about the quality of some of the sampling and how it was done. So that is what we're going to be doing. We just started, we're just completed the first quarter of our projects, but I wanted to show you that we have a good access to all these SIMs. And what we're doing on a per state, which is, this is an example from Virginia, is to take the samples that the USGS is collecting and try to get a little bit more detail where these samples have come in. For example, you will see on the table there weather channel samples. That may not be as sort of high dependence as others may be. So we want to get a little bit deeper into that. On the mining and extraction, we have very simple rules. We want to deal with precision mining methods who do not create any kind of waste or unnecessary waste. This is how you mine actually first mining a resource, not a waste product. And as you can see, we feel we have a lot to learn from technologies from other industries. You will see a variation possibly of horizontal drilling to horizontal mining. We are looking very seriously about micro tunneling. And also in one case, we're working with a company to see if something that is well utilized in mining right now, called high wall mining, can deal with surface exposures of those materials. On the processing arena, my team that knows more about it than I do, classified all these processes, as you see this slide, as physical separation, chemical processing, or other types of separation. And underneath, I asked them to give me some idea of what are the emerging technologies that would be of interest in this space, anything from using, for example, supercritical CO2 for extracting these minerals, biological extraction, and so on. So what we're doing here is we're looking at new technologies that we are engaged, but also all the technologies developed from anywhere, and we're putting through a screen of responsible extraction. And as I said before, certain of those technologies will not pass for us because they will not satisfy the bar that we have created. I want to finish also a little bit to those who are not familiar, to talk a little bit about the resources and reserves. We're talking about currently resources. Every nation has a different system that they use. We use something developed by the Society of Mining, Metallurgy and Exploration, an SME, which is actually accepted for the Securities and Exchange Commission. When I was president of SME, I was very much engaged in that development. Many people in my team are, but there are a lot of other global systems out there, and we pay attention to all of them. So as you collect information from resources, you can sort of increase your confidence by going from inferred to indicated and so on. But when you start talking about reserves, you bring the economics into the equation, right? So a reserve is not a geology term, it's not a mining term, it's an economic term. And what it means basically, you take all your costs, you find that total cost, and that overall production total cost must be less than the selling price. In other words, the global price must cover all your costs with some adequate, let's say, margin for your profit. And that is quite easily to understand if you look at oil. You know, oil fluctuates up and down, but you don't have one or two countries doing 80% of the oil production. So it is more under control. In this particular case, that is very troublesome because global price, because the 85% coming from one producer, is subject to dumping and arbitrage trading. So it will be a totally different system that we need to develop to calculate reserves and a totally different incentives. I put a list of barriers or issues and incentive possibilities that I will let you read. I do want to say two things. We are very much aware of asserting mineral titles between mineral owners, surface owners, mining companies, and everybody else. Things are not as simple as some people they believe they are. Also, regulatory jurisdictions. This is something that we are addressing head on because there are some issues there. For example, is the processing of that material, is that a coal mining operation or is a mineral mining operation? This is quite an important question later on to discuss. If you're talking about recovering something from a geologic formation and all that, then you have to see this is a first mining opportunity. What happens if, for example, you are looking at byproducts of mining, right? You're talking about waste products. So if you're talking about waste products, what happens if the mine or the, sorry about that, things going crazy. What happens if you have a situation that the mine or the plant is shut down and you don't have that first mining anymore to get your byproduct? So with all that, also a final thing to mention is We want, if we talk about encouraging jobs and opportunities at the coalfields, we need to develop the manufacturing facilities at the coalfields. It's not going to be much of economic development activity here if the only thing we do is we develop the raw material and we send it not to China, we send it to California for processing. All the high-tech jobs are going to go over there. So please be in mind, while we're talking about all that, we are adamant that we want to see downstream processing activities coming where the primary production is. Otherwise, we'll never achieve the goals that we set. And of course, the incentives need to be there, and Grant mentioned some, and they need to be well thought on that. I want to finish basically with one statement from someone who's a real leader in our industry and represents one of the three major mining companies. Our basically partnership very much observes that is the success is not measured in ounces, carats, or tons, but also measured by how we improve people's lives. This is the undermining theme of our Evolve Central Lab partnership. Thank you very much. I'll stop here, and sorry for the extra noise from all my phones running all at the same time.
That's quite all right, Dr. Karmis. Really thought-provoking presentation. We look forward to continuing to monitor your work in the region. And up next, for an industry insider perspective, we have our Associate Member Chairman and the Executive VP of Strategy and Business Operations at Green Cement, Inc., Danny Gray. Thanks for being here today, Danny. I'm excited to see what you have to say about critical minerals and rare earth elements in coal combustion residuals. And
Great.
I'll get your presentation up for you.
Yeah, if you don't mind, pull it up and we'll just flip through it. Good morning to everyone. You can jump to slide 2. Get it. What I would like to talk about, what I'm going to focus on is a subset of the overall resources that where we are going to be looking for rare earth elements, critical minerals, that being coal combustion residuals, and basically kind of these are the line items that I'm going to touch on very quickly in the following slides. But basically, coal combustion residuals by definition is fly ash, bottom ash, flue gas, desulfurization type products, all lumped in. The typical method that we use is slurry impoundments or landfills for those byproducts. That's what industry has typically used those for in past years. Utilizations, because as we all know, these resources have been a source of important construction products. There's broad distribution, a well-evolved system for utilization of coal combustion residuals. But we also can look at those as a resource for mining and basically to recover rare earth elements, typical concentrations being 300 to 800 part per million. There's a large volume of production of CCPs, CCRs over the decades. The data that's out there that many of you can find and look at if you want to is the American Coal Ash Association publishes the annual production and use survey. Department of Energy collects and has a wealth of information on utilization as well as storage of CCRs. Depending upon who you talk to, there's estimated 1.5 to 3 billion tons. My numbers on my own indicate probably the closer number is probably 2.4 to 2.7 billion tons out there. In terms of sites for mining these materials for critical minerals, we kind of look at it and say, well, there's small sites are in the 1 million tons of storage capacity. Large sites are probably 20+ millions. Next slide. So these are the bullet items we'll talk from, and then I'm going to kind of go in because I'm not sure who all is on here and how much you know about coal ash, but basically the residuals are fly ash, bottom ash, slag, flue gas byproducts. The top picture in this slide is a picture of fly ash. It's typically about the same consistency as baby powder or face powder, which means that from a mineral extraction standpoint, it's got a lot of the energy already imputed into this mineral. because it's already ground into a face powder consistency. As we said before, it's about 1.5 million to 3 million tons, depending upon who you're quoting. I would say closer to 2.5 billion tons out there in terms of that. Surface impoundments was the older technology for handling a lot of coal ash. You basically slurried the materials into an impoundment and let them settle out, and then once the water was cleaned from the particles, it was went through wastewater treatment or wastewater discharge. In the latter years, everybody switched to landfills. Not everybody, but many of the utilities switched to using the material, collecting fly ash dry, putting it into landfills. So those materials are going into landfills, and that's the more recent thing. What method of handling them? The use of impoundments is essentially restricted now by the EPA regulations. Unless you have a synthetic liner system under it, nobody's using nobody's using slurry impoundments, and all of those are basically being shut down if they haven't already been shut down. So there's a tremendous number of facilities out there that have closed either landfills or old slurry impoundments. Some of these could be used as resources for recovering coal ash in order to generate it. The critical minerals, the rare earth elements, like as we said, 300 to 800 part per million in central app type coal derived coal ash. There's a lot of work been done, probably indicates that we're closer to the 500 part per million for in the certain particle size range. So what we would target is basically the sources of fly ash that are out there either in impoundments or landfills, because you've already got them ground into face powder consistency, and that's where you see the most enriched concentrations of rare earth elements. Next slide. In terms of where they're at, as we said, there are higher concentrations in basically the smaller particle size. The upper slide is what fly ash looks like. It looks like ball bearings under a microscope. That's really why it's so sought after as a replacement for cement and concrete, because fly ash actually can take out 100 pounds per cubic yard of cement and plug this material into it, and it actually makes the concrete stronger and better and more importantly, greener from a CO2 emissions perspective. Typically, if you have combined ash impoundments or combined landfills that has carbon and sulfur byproducts mixed with the ash, then that makes it a little bit more difficult to recover. As we said before, Central App has higher rare earth element concentrations in the -200 mesh or 70 micron mesh size. We basically have seen a lot of evidence of roughly 500 part per million type concentrations. So from a simple, I like to tell people, we're talking about a tremendous logistics assignment to try to recover CCRs from various impoundments and landfills and process those, because you're basically handling a 500 part per million material. So it's going to take a lot of logistics, a lot of expense associated with that. And one of the things that I have pushed for, and I believe is important as we go forward, is to develop extraction processes for the critical minerals, such that along the way we can actually generate from this recovered ash materials, we can recover ash that is usable again in other applications besides just the recovery of the rare earth elements. Next slide. So that large material handling is basically due to the fact that we get broad distribution of the 800 plus facilities scattered around the US, predominantly large volumes in the eastern half of the US, but there are geographically, we've got a lot of facilities scattered around. In terms of impediments, from a regulatory requirement standpoint, I see that as an impediment for harvesting this material from landfills or impoundments. Solid waste permits cover all of these facilities when they were active. Closure related permits and or requirements cover these impoundments or landfills now in many cases. And if you're going to reopen those, you have to deal with both solid waste approvals as well as wastewater permitting, air-related permits possibly, and of course, one of the big ticket items is future liabilities or liability assumption related to the landfills or the ash impoundments. Since these are mostly owned by utilities, in working with the utility industry in order to define how the materials would be recovered and whether there's future liability associated with the subsequent mining and harvesting activities. When you're recovering ash from either a landfill, which typically would have 15 to 20% moisture in the material when it was compacted and placed, or if you are dewatering ponds, old impoundments, you have to go through a dewatering program. And then of course, more than likely, depending upon the extraction technology, you're going to be drying this material at some phase. So a lot of the steps that you'll be going through are the same steps that we would be doing in the ash industry if we were recovering coal ash and to make it into a pozzolan or a cement replacement as we are today. So probably what we will see is centralized processing with multiple feedstocks coming from multiple plants. We have a pretty strong concentration of plants in the Ohio River Valley and the rivers that are tributaries to the Ohio River. So there's a lot of plants in the region that we're under focus here in the east, as well as up and down the Ohio River Valley and the Mississippi River Valley. So a lot of plants. So you got concentrated volumes, a tremendous number of tons of resources in terms of that. And you also have the water logistics capabilities of merging the materials from a logistics cost standpoint to get them to centralized processing plants. So the goal would be to create a product that once you've extracted the rare earth elements to the extent that along with through that processing facility, if you can generate materials that would also be used in other applications such as replacement for cement. In that way, you can generate a co-product or a co-product revenue stream in order to offset some of the materials. Now, from a production trend standpoint, as we know, fly ash production has dropped off, or coal ash production has dropped off. We were generating about 140 million tons a year at one time. Now we're down to about 68 million tons per year, and a lot of that, more than 50%, is being utilized. As much as 74% of the gypsum product is being utilized in different markets. So next slide. So the utilization industry is a very mature market. I'm going to talk about these just very quickly, but basically fly ash is used. Its primary highest embedded value is to use it as a replacement for cement and concrete. Typically, if you're building bridges in saltwater environments, you want as much fly ash as you can put into concrete in order to reduce the sulfate attack from salt waters to prevent corrosion and spalling the concrete off of the rebar. So it's a valuable resource from that perspective, but it's also valuable from to the extent that we can extract the rare earth elements. So the other things that you can see this list of products and stuff that the materials are used in, depending upon where it's in commonly in products all around us in everyday life. Most people are not aware of that, but whether it's fly ash or gypsum or bottom ash, they're used in many of the products in our households and in our life. And it's been a mature industry for many decades. So this is not new. So the benefit of, as we approach rare earth element harvesting of the CCPs from facilities in order to recover the rare earth elements, we would like to be able to end up with a product that has more mass market attraction and mature market development. Next slide. Just briefly mention, this is the trend. You can see the blue, dark blue bars. That's the trend in production of ash. You can see the percentage utilized, which is the red line, as continues to go up. So the trends are for less and less materials. And what that means to the industry is already starting to go into landfills and recover, harvest materials in order to extract the coal combustion products that we need for use in concrete. So the harvesting operations are already starting. So the synergies between rare earth element extraction versus coal ash harvesting is already there. Next slide. This data is from the American Coal Ash Association. I'll point out just a couple of things on the top left. Basically, 28 million, 26 million tons are generated. It's a lot of data. I apologize for this thing, but I wanted to put it in there in case if you look at the slides later on, you want to go back. Basically, about 64% of the fly ash is utilized today. 74% of the gypsum byproducts are used. So a tremendous amount of material generated. 69 million roughly, but a lot of it is being utilized in today. And then trend is going down, obviously, as plants are getting older and shutting down. So the recovery of landfill materials and impoundment materials is going to be the trend that we'll see much to replace what we refer to as current production. Next slide. So the key is from a kind of a summary perspective is that, we have large volumes of material out there, coal combustion residuals, setting in impoundments or landfills. So recovering these materials as a source for rare earth elements and critical minerals is something that will move forward because we're going to be recovering them anyway for use in concrete. So utilization brings multiple benefits. It brings the environmental benefits coupled with the extraction process because you're mitigating the environmental in some cases where ponds may be leaching or have some groundwater impact, you'll be removing these minerals and processing them and put them into an application. Particle sizing is already completed because the grinding process for the coal and the generation process for the fly ash components is already done. So the face powder consistency materials is important from a mineral standpoint because the energy has already been imparted to make those materials small particle size, and that's where we want to go find the rare earth elements is in the smaller particle size. Trends in the construction market are driving needs to harvest. The need for replacements for manufactured cement, Portland cement is greater and greater. So as a trend right now, we're moving towards green cements or low carbon cements. And so this recovery process for rare earth elements could play a vital role in a dual purpose from that perspective. The key thing is logistics cost. As we all know, commodity pricing is always tied to logistics. So what we want to focus on is those centralized processing plants that have good logistics in order to get the materials there. Next slide. I think that might be the last one. So I'll turn it back over to you.
Great presentation, Danny. Excuse me. Let's see. Need to get that minimized. There we go. It's always great to hear from our associate members like you, Danny, and we appreciate your continued work with the board. Let's see, we'll move right on to our last speaker now. That's Dr. Charles Sims. Dr. Sims is the Energy and Environment Program Director at the University of Tennessee's Howard H. Baker Jr. Center for Public Policy. And he's here today to discuss the Institute for Advanced Composites Manufacturing Innovations, that's a mouthful, project to assist with the development of technologies to extract and produce critical minerals from coal and coal ash. Let's go ahead.
Great, thank you. Thanks for having me today. And I know we're running short on time and I want to save some time for questions, so I'll try to move as quickly as possible. So we are the Southern Appalachian equivalent to Michael's group in Central Appalachia. So what he was talking about, a lot of what he is talking about will apply to the things I'm going to talk about today, so we can move quickly and just kind of focus on some differences between the two projects and things. So our mission, like Michael's, is to revitalize these distressed Southern Appalachian coal communities and reduce reliance on foreign imports from, as we've talked about, from other foreign countries that we're importing currently REEs and critical materials from right now. And the objective here is to develop and deploy these new technologies, but also valuable non-fuel carbon-based products from coal and mostly from coal waste in the Southern Appalachian Basin. And you can see a map there of what the Southern Appalachian Basin includes. Lots of coal fields in Alabama, a few remaining coal fields in Southern Tennessee, and then just a little bit of Northwest Georgia there. So really our region where we might be short on coal, we are flush with coal ash. And so our key resource base is really the coal ash. Between those three states, Alabama, Georgia, Tennessee, we've got almost 10% of the US inventory of coal ash. And most of that luckily is concentrated at sites that are owned by Southern Company or TVA. So once you bring those two folks into, or bring them at the table, you have access to a lot of the coal ash that's in this region. Typically the RE concentrations, as Danny was saying, down here, they're about 400 parts per million. That's about 5 times what they are in the coal. So the important point to take home here is that once you burn it, as Danny was saying, the concentrations go up significantly when you're looking at the coal ash versus the virgin coal itself. But we're also looking at surface mines and underground mines and coal prep plants in the Black Warrior Basin there in central Alabama, acid mine drainage, all those co-production sites, dewatering projects, plant waste sites, all those are also potential resource bases we're considering down here as well. The 3 features of this program in particular, we feel we have a really special RE innovation ecosystem. As we said, we have lots of coal ash. We're then combining that with unique manufacturing R&D capabilities, specifically in carbon fiber. So IACME, the Composites Institute located here in Knoxville, has a long history of dealing with carbon fibers especially, but our 3D printing, batteries, and graphite specialization coming at Oak Ridge is also a selling point for us as well. We also have a lot of novel separations expertise. So as Michael was talking about, one of the key pieces of this is taking the ore out of the ground or the coal ash and separating the rare earth elements from that raw material. The separations piece is costly, and it's also very environmentally damaging. And so we have some novel expertise both in terms of biological processing with expertise at Oak Ridge, electromagnetic processing, and then kind of improvements over thermochemical separation processes, as well as a lot of high performance computing that will be used to kind of optimize those separations processes to make sure you're getting the biggest bang for your buck. The key piece of this phase 1 project is a technology innovation center. I won't go into a lot of details on this. But the piece of this would be that we are developing at the end of this program a technology innovation center around extracting rare earth elements and critical materials from coal waste here in Southern Appalachian Basin. Here's an overview of our team. So I is the PI at the Baker Center here at UTK, but we've got team members scattered across Alabama. So Dr. Rona Donahue is heading the resource assessment team at the University of Alabama with folks from the geological surveys in Alabama and in Tennessee. Riley Flowers from Southern Company is heading our waste stream reuse team. I, as a background as an economist, am heading the strategies for infrastructure, industries, and business. And then we have a big team from Oak Ridge and IACME that's heading the technology assessment piece. IACME is leading on the Technology Innovation Center. And then we have a stakeholder outreach and education component that is being led out of IACME as well. Lots of community colleges involved with that stakeholder and outreach piece as well. Why is this important? So as we talked about, Southern Appalachian Basin production has fallen a lot over the last decade, leading to a lot of job losses. We were already a small producer, relatively speaking, to our to the other teams in Central and Southern Appalachia. But we had a lot of processing facilities in the region as well. And we don't expect this to turn around, right? Most of this is being driven by a shift away from coal, at least in this region in electricity generation that we don't expect to reverse. One of the key features of this region, though, is that we have become an automobile manufacturing hub. And so what you see here are all of the automotive manufacturing facilities. So these are not just businesses, these are actually the manufacturing facilities for different automobile companies. And you can see 3 there that we've highlighted that are specifically related to electric vehicles. There's also 4, maybe 5 now, battery manufacturing facilities that are in these 3 states as well. As you might expect, if you're making electric vehicles, you want the folks that are making the batteries to be near those facilities. And so since a lot of these critical materials are going into the production of these batteries and the vehicles themselves. You forget that a lot of the carbon fibers that go into the production of these electric vehicles become important as well. The downstream piece of this is really important for our particular project here. Stakeholder outreach and education. So I won't go into a lot of this either, but IACME has a long track record of working with local communities, state and local governments, has a lot of connections with business and industry partners, especially in automotives, and then economic development for those local regions as well. I wanted to highlight 2 challenges and opportunities. So our project specifically has been focused on supply chains. We've been talking a lot about this today. There's data exists, as Danny was talking about. I mean, using fly ash is not a new thing. This industry's been around for a while. So there's lots of data to characterize what that upstream component of the supply chain looks like. We can characterize who are using the rare earth elements in the critical materials, automotive being one of them, but construction being another. It's those key pieces in between that we don't know. Right. So what this project is really trying to do is to kind of characterize what those midstream supply chain linkages would look like in order to make this whole supply chain sing. And so obviously, if you've got really sophisticated and efficient upstream uses, but the downstream isn't there, that becomes a problem. We're also focusing a lot on trade policy. So obviously the world price of all these things is going to be dictated by stuff that's happening outside of our basin, right? It's going to be determining by what the world price for these resources are. And so we're using a lot of information on trade data to figure out the extent to which we need to be price competitive when it comes to imports and exports of these goods as well. Finally, we want to talk about kind of the underserved communities. We're going to be doing a lot of stakeholder interviews with folks that are living in these communities. You know, the catch-22 for these folks is you say, well, they are now living with the legacy costs of having coal ash ponds and slurries and things like this in their communities. So they should be the ones that benefit if there is some sort of economic boom to pulling rare earth elements and critical materials out of these things. But on the other hand, many of these communities just want to move away from these in general, right? They don't want to be reliant on resource extraction anymore. They want to diversify their economies. And so we're going to be doing some surveys and interviews to feel out how people that live around these waste resources feel about potentially revitalizing these things. So I know that was quick, but I wanted to save some time to have some Q&A. So that's all I have for today.
Okay, perfect. Thank you so much, Dr. Sims. To your point about the EV manufacturing in our region, I'd like to say that we had VW's Matt Renna on a previous webinar to discuss Volkswagen's role in EV production and battery sourcing in the region. And that's available on our website now if you want to review that. We do have about 15 minutes or so, 10 or 15 minutes for questions, but we don't have a whole lot of questions in the chat right now. Let me see what I have in front of me. I have a question on behalf of our board members, actually, which, you know, is legislators, governors. So how can we expand domestic production and manufacturing, or how can they help to expand domestic production and manufacturing of critical minerals? What can legislatures and you know, governors do to encourage the kind of manufacturing and, you know, expansion that we need?
Attorney, I'll take a stab at it from my perspective in terms of, and I'm interpreting the question of how can we facilitate the mining of the rare earth, recovery of the rare earth elements from the CCR resources. I'll focus just in that area. Is that, you know, as I went through my slides, I talked a little bit about some of the regulatory impediments and or, you know, in some cases they're legislative. Some of the states, as an example, North Carolina went through a legislative process where they mandated ash impoundments be closed or remediated by removing 100% of the material and utilizing the materials. I'm not particularly a fan of having that as a legislative mandate, but what I would say is in many of the states, working with the regulatory agencies in order to facilitate the harvesting of the minerals in order to make them a resource that we can utilize. I would encourage our legislative members to work to the extent that they can with the regulatory agencies in order to streamline some of the permitting processes, because it's like a lot of environmental permitting processes, they can be stalled, drag out over a number of years. But in the case of using the coal ash resources and recovering those, the advantage is you're remediating, an ash landfill or an ash impoundment. And to the extent that we can facilitate and streamline the permitting so that those projects can move forward efficiently and effectively, I would definitely believe that that would be a help to the overall recovery process.
Anyone else want to lend their
Yeah,
opinion?
I would like to add also another point. What Danny mentioned is of course the critical and the most important one. The second is, as someone who has been in the R&D business for a long time, and I know Grant will appreciate that as well. Most of the work that we do, most of the R&D work we do, and the tremendous help we get from DOE and NETL in particular, also requires significant amount of cost share. So I think the legislatures also should help in putting some state cost share funding available for certain projects which are high priority. That will allow the researchers to get better access to government funding, will allow, let's say, a better approach to the whole thing, and that will be tremendously useful. So I would say one, that will be something to be done. And of course, the second thing is to try to develop other kind of incentives for this industry. Whatever they are, I don't know. We need to come up with something a little bit more, how can I say, more innovative. Nobody wants to nationalize an industry, right? And no investor wants to put money on something which is based on some kind of a subsidy. We need to come up with something different. And the states have a role to play on that as well as the federal government, I think.
Okay, anyone else?
So I don't know that I have much to add to what's already been said. I think the main points are already made. But maybe I'll say something that kind of relates to the other question I just saw pop up in the chat as well, and tie these two together a little bit, because and I think what Michael said is important. If there are ways to incentivize, and so with the infrastructure law, DOE and the federal government is working on ways to help incentivize the growth of these things. One of the biggest challenges is that, it's been mentioned a couple of times already, is the creation of midstream processing that's just really missing in a lot of for a lot of these critical minerals. And China has the ability to sort of pull the bottom out of markets and to essentially kind of threaten. They have the possibility. So if there's an organization, a company that wants to make electric batteries for electric vehicles, and they need to have a secure supply chain, right now China is where they have to go to get it. And so anything that we can do to help stand up, and so people who are going to be on the purchasing end, the automobile companies, manufacturers, they're going to want to have some security. So anything that can be done to help demonstrate security for these minerals in that midstream is going to be critical.
Okay. And does anyone else want to touch on the question you referenced from the chat? Is how does China and its efforts to control rare earth elements affect future development of technology in the Southeast and the U.S. as a whole?
Yeah, let me make a comment, because we refer to China all the time, right? But we need to give them credit from the point of view that for a number of decades now, this is nothing new. I think the Chinese have seen raw materials as a potential sort of source of, let's say, global supremacy. At some point, they said they want to be the equivalent of the Middle East of oil. So they have been not just developing rare earths, they have been purchasing reserves, and they have purchasing even resources all over the world. And most recently, because they were unsuccessful to buy properties in one particular country, right, that they wouldn't sell, they ended up having a long-term purchase agreement. So they're buying everything that they produce, although they don't own it. The interesting thing about China, though, is also, since you're talking about electric vehicles, I think last time I was in China was 8 years ago, and I was told there were more electric cars in China then that twice the entire world had available. And the Chinese have a goal, the way I understood it, by 2030 to be 100% all battery operated vehicles. According to one source that I trust, that very knowledgeable, there is even a real possibility that the Chinese will not have any rare earths to be selling to anybody in 20 years from now or 10 years from now. That will be another indicator of that, but you cannot manage batteries at that scale without using all your resources for that. So I think the Chinese have a plan and have a vision, and it is very difficult for us to make sense because, as I said, we cannot compete price-wise, and their price is vulnerable to dumping. So a free economy cannot really easily compete with a centralized economy on those kind of conditions.
Okay, anybody else have anything to add?
Yeah, I'll just add, kind of following up. I don't think the question is that we're going to dominate China in this area, right? I mean, it's a question of, and when I talk to this up to a lot of my trade economist friends, what they recognize right off is like, oh, we're offshoring the environmentally damaging part of the supply chain. What's wrong with that, right? And so when you think about it like that, it's like, oh yeah, we are just sort of offshoring this environmentally nasty process to another country, which we've done for decades, right? Not that that's good or bad. That's just that's not necessarily something new here. But the question becomes, how much are firms willing to pay? How much higher are they willing to pay for some sort of security premium, I guess is the best way to call it, for sources that are produced here in the US, right? So if there are greater interruptions from China, that premium is going to go up. It depends on how much they can stockpile it. It depends on how much other competitive companies or competitive fringe countries can boost their production, right? So it depends on a lot of stuff. But that premium is basically going to dictate to legislatures, both the state and federal level, how much of that needs to be moved back to the United States, right? It's not going to be all of it, but there needs to be some amount of production domestically that would shield us from those dumping and those interim times when China puts on export quotas and things like this that would drive up the price. So the real question is how much of that needs to come back, right? It's not all going to come back, but the question is how much needs to come back. And I think we have a lot of folks that are importing rare earth metals from China right now that can tell us how much they're willing to pay, how much higher they're willing to pay for that domestic source, and that'll help us figure that number out.
Okay.
Yeah,
Anyone else?
One last thing to kind of add to this discussion is around standards and international standards for certifications and standards for all points in the supply chain process for critical minerals, and DOE and other organizations across the U.S. People in universities are a part of ISO and working towards helping develop those standards as well.
Okay.
I think if I can make just one very quick point, having been in a couple of battery seminars, including the one that SSEB had, we need to try to educate also the battery world out there of what is going on, because I don't think they fully realize it. Every time I see somebody talk about batteries, they have a curve and they say, as we produce more and more, the cost is going to go down and down. And I said, how did you figure this out? Do you think your raw material will decrease in price. And they said, yes, because there's going to be higher demand. Well, it doesn't work like this, because if you need more, it's going to be a bidding war to the highest bidder. So they need to understand, because eventually, as Charles said, as you pay that premium, the batteries, for example, will have to be out there. And in their logistics right now, in my view and what I have seen, they're focusing on reducing cost of raw material, not actually increasing it. So they should be educated on that as well.
That's a great point. Well, we're up against our time now, so we're gonna have to wrap it up. I want to thank all of our presenters today for giving us an information-packed webinar. This topic is, it's a pun, but it's a critical topic to discuss. Thank you to our attendees today. And if you missed any part of today's discussion, video will be available on our website within a few days. Just give us a little bit of time to put it back together. Please ensure you're signed up for our newsletter to receive future webinar and in-person event announcements. We have big things to announce very soon. Okay, great talk, everyone. Thanks for being here. We'll see you next time.